Supplemental math videos from Circle Christian School.
And so the answer is, why haven't you upgraded? You can upgrade to shading.
Okay, Algebra 1, Chapter 3, Section 3, Rate of Change and Slope. Since we're doing linear equations, everything is going to be constant, because if it wasn't constant, then when we graphed it, it wouldn't come out to be a line. So each step has to be the same. So you're going to see some things, like maybe some XY tables, and they're going to give you some different values. And what they're going to ask you is, just by looking at the table, is it linear? And you may think, well, I'm not real sure when I look at my table if it's linear, so we're going to find out a way. Okay, to find out if there's a constant rate in change, we need to go change of y over change in x. And we're going to have to compare each individual instance. For example, let's start with this one and this one. So my change in y, it is from -6 minus the -8. And then my change in x is going to be 1 minus 4. So -6 minus a -8, change that to plus. -6 plus 8 is 2. 1 minus 4 is -3. So far in my first example, my change of rate is -2/3, or 2 over -3. So now let's go from the second one to the third one. And so we're going to have -8 minus a -10 all over 4 minus 7. So that's going to be plus plus. -8 plus 10 is 2. 4 minus 7 is -3. So far we're in good shape. Now we're going to compare the last two. Nope, I don't want to do that. So we're going to go change in y. That's going to be -10. Boy, I do that a lot. -10 minus a -12 all over 7 minus 10. Again, plus plus. That's going to give me -10 plus 12, which is 2, and 7 minus 10, which is -3. That tells me that this table is linear, because each rate of change is the same. All of those rates of change are the same. Okay, but you have to test each one of them. Okay, let's move on and talk a little bit about slope. We have 4 types of lines. And I'm going to draw them here. Our 4 types of lines, this would be, or 4 types of slopes on these lines. This would be a positive slope because it rises from left to right. So that's positive and rising. This one would be negative. And falling. This one has a slope of 0, and it's neither rising nor falling. And the last one, as crazy as it looks, this one has no slope. It's impossible. If you go to the top of this mountain and try to ski down it, you will notice it's a cliff. So there will be no skiing today. So it will just be falling. So we have positive rising slope, negative falling slope, 0 slope, and no slope. You'll notice that positive and negative, those are going to be diagonal lines. 0, that's going to be a horizontal line. And then all vertical lines will have no slope. So how do we find it? Well, we have a slope formula. Slope is going to be represented as m from now on. Okay, m is the letter they use for slope. And the slope formula is y2 minus y1 all over x2 minus x1. Okay, change in y over change in x, which is what we did for rate of change just a couple of minutes ago. So to use this, we're going to need a couple of coordinates. So I just randomly picked two coordinates. You need to identify which one of them you want to be your first coordinate and which one of them you want to be your second coordinate. I promise you, it doesn't matter. I picked the first one. You could pick the first one being negative 2, 4. It will come out the same in the end, I promise. So let's substitute in the y value of my second point. I'm going to color code these. Okay, so y2, the y value of my second point is 4. The y value of my first point is 6. The x value of my second point is negative 2. And finally, the x value of my first point is 3. So let's do some substitution. y2 is 4. I'm going to subtract y1, which is 6. x2 is negative 2. And I'm going to subtract x1, which is 3. 4 minus 6 gives me negative 2. Negative 2 minus negative 2 minus 3 is negative 5. And because I have a negative over a negative, that makes that positive 2/5. So this is going to be a positive slope, and it will be rising. Positive 2/5, and it will be rising. Now, one final thing to look at, and we'll be done. Let's go ahead and look at a graph. And let's say I have this point and this point. And I'm going to create a line out of those. That's not a good line. Okay, I'm going to go with that one. And if they ask me to find the rate of change, which is the slope, there's two things I could do. I can use my slope formula. y2 minus y1 over x2 minus x1. So I'll have to label these coordinates. This one is 4, 4. And this one is negative 3, 0. So I could substitute those in. I'll use the negative 3, 0 as the first one and the 4, 4 as the second one. And so my y2 is 4. My y1 is 0. My x2 is 4. And my x1 is negative 3. Watch that minus a minus. So that's going to be 4 over 7. Notice that's a positive slope. It is rising. We could tell that by looking at the line. It's rising from left to right. And so what's another way to do it? Well, rate of change is also known as rise over run, which slope is as well. And so how many spaces do I rise and how many spaces do I run to get from point to point? Well, here I rose 1, 2, 3, 4 spaces. And here I ran 7 spaces, which gives me the exact same answer. So you can do it either way. Use the formula or take the rise over run directly off the graph. Okay, so that's a little under 10 minutes. Chapter 3, Section 3, Rate of Change and Slope.